hope you all practiced whatever was taught in the previous session, right? And used that to submit on code forces or whatever website you're using. And if you, because you need to be familiar and comfortable with whatever, like the way to quickly iterate over vectors and all the methods of vectors to move further with the non-data structures, because all of them use similar functions. And if you haven't done that, this is going to create a problem. Like you won't fully understand what's going on over there. So I hope you're already familiar with vectors and how to use them. Can I get a yes or a no? I'll take that as a yes, I guess. Okay. Uh, I'm gonna start with pairs that I skipped last time due to shortage of time. Then I'm gonna revise iterators, and then we're going to move on to the data structures. So often, like you would have created a struct in C, right? You were given some name, let's say point. Or let's assume the struct is for like a pair of coordinates int x and int y. So C++ already has this feature for you implemented in the STL library. So you can declare a struct using it's called a pair. It can only have like two data, two integers or whatever you want to store, two data blocks. So we'll declare it like if you want a pair of integers, you're going to declare it like that. Let's call it P. And you can access it using, you can assign it using p dot first equals 1 and p dot second equals to 2. And you don't need to, declare a custom struct for this. And then to print it out, I can do to out p dot first. And I can print out the second one. It's going to print out 1 and 2. The good thing about this is that you can change one thing from this thing to float. You can change it to string. Anything that you want to change to, you can change it to even a pair, another pair. You can, if you want 3. Suppose if you don't want to store 2 values, you want to store 3 values, you can use something like int. I mean, if it gets more complex, see, so now it says that this assignment is invalid because p dot second is actually a pair of integers. So I can't directly assign the value to it. Well, I have to do something like assign second dot first. I'm going to assign 2, and to second dot second, I'll have to assign 3. And you can't print out a pair just like that. You'll have to print the values inside it. And second dot second. So for 3 to 4 values, you can use branching of pairs to print it out to quickly write it out. Otherwise, if it gets more complex, it's better to declare a struct. So what is like the advantage of using pairs? See, first of all, it's like it has an internal comparator to it. So if you often there are problems like this, like I've recorded several times that you're given a pair of objects, right? Suppose coordinates x comma y coordinates in a 2D plane, and you have to sort them according to the x value, the pair of coordinates, and you want to do that. But if you store them in 2 separate arrays or vectors, if you store that vector in x and vector in y, and then you store it over here, let's say 1, 2, 3, and 4, 5, 6. So essentially, you want to store the coordinate 1, 4, 2, 5, 3, 6. Then you can't actually sort them. If you sort one of them, you can't. That won't preserve the coordinates, right? If you sort this thing in reverse order, this is going to become 3, 2. This is going to become 1. But the second vector remains as it is. It doesn't have anything. So essentially, you need to store it as pairs and then sort it according to x value. In that case, what you're going to do? I'm sorry, you're going to declare a vector of pairs, solid vec, and I'll do vec.pushback. What happened? Yeah. Sorry about that. Yeah. How do you push back a pair? So a pair into a vector. For a regular int, you could have done push back and then 1. Over here, you'll have to do something like this is called a constructor, constructing brackets. You can do 1 comma 2. Like that, you can push in a pair. There are other methods to do it, but I feel comfortable in this way. And let's say I'm gonna push in 4 comma 5. I'm pushing 4 comma 5 first and 1 comma 2 later. And then I want to sort it according to the x value. So internally, if you sort it just like that, vector begin, vector end, and let's print the values out. You might remember this from the previous session that I don't want to iterate over it like entirely. I can use like I don't want to do int I equals to 0 and vector sizing out. I'll just do auto p in vec. this could have been as well as been a pair int, but who's gonna bother writing that? So I'll just replace it with auto, and then I can print out p.ff. Sorry, first, second, right? I'm printing it out, and if I compile it, so I print 1, 2, and then 4, 5. So it sorted it by default according to the first value, that's x, because initially I had pushed back 4, 5, and then 1, 2, right? So this preserves the order of it. If you want to sort it by a second value, then you'll have to pass in a comparator function. I'm going to talk about the comparator function at the end of this session. So it's similar to what you did in qsort, right? In quicksort in C, you pass in comparator function. For special cases, you'll have to do that. Otherwise, in most of the default cases, it's just a common sort works, because internally a pair gives preference to the first one. It has an internal comparator defined. Okay. Anything? No messages, right? Okay. Any doubts till now? Anyone can unmute and ask. It's actually really problematic to read the chat and so that's so you can unmute and ask anytime if you want to. Should I move on?
Hello.
Yeah. Okay. Yeah.
Yeah. So can we have a pair of 3 elements like this int? So.
So that is not allowed. There is something called an array. You can declare an array of 3 elements. Something like 3 comma int. Sorry, it's I think int comma 3. There are some methods. There's something like that. Something like this. I'm not going to talk about right now. You might want to read up on it. But the problem with this thing is, if you want to declare an array, this thing array is different from C arrays. Okay, it's somewhat different, but the data type will be the same for this. You can declare it like that. Otherwise, if you want, see, it's called pair because it allows only 2 of them. So you cannot have int comma int. But if you want to get around it, then you'll have to declare your own struct over here. 3 point.
Generally, to do something like that, you might want to like put a pair inside the pair. Like
yeah, that's what I talked about before also. You might want to do that, or if it gets complicated enough, then you can do int y and the end declare it on your own. But yeah, that's true. You might want to do pair of. So the first thing is int comma int, and the second one is the second element of the pair is another pair in which you can store the other two data.
I think there is STD tuple is there for more than 2 values. Right?
Oh yeah, there's a tuple too. I forgot about that. I don't exactly remember the syntax of like how do you declare it. I didn't get around to use it that much.
Same thing as pair, but the number of arguments can be whatever.
Oh, so I can okay.
Yeah.
Nice. Okay. Yeah. I forgot about tuples. I've never actually used them. So I can keep it like that. Oh, then it doesn't allow me to use first and second because first and second have been especially defined for pairs. Over here, I'll probably have to use indexing. Okay. Even that's not allowed. Let me look at this. Tuple TTB. How do you index it?
I think it is
You index
STD
is std
get.
get and then std get within angular brackets the index, and then in like it's a function. So get
Oh, okay,
angular
like
bracket
that.
0 and then
It's
inside
like
that.
this. Get 0 and then I pass
Yeah,
in the tuple.
I think so.
Okay, let me try this with 3. Whenever I face a tuple kind of situation, I have declared my own struct. So I've never really bothered with this.
Can you please explain the get 0 thing again?
Oh, yeah, 1 second. Let me test this thing once. So it sorts it. I think I already know the first value. Yeah. So get is like it's essentially a function. It's a function into which you pass the argument is gonna be the data structure from which you wanna get. So in this case, the data structure is a tuple because I declared a vector of tuples. And within the angular brackets, like overhead define int, that's the template variable. For that, you're gonna pass in this thing, the index that you're gonna get. This is actually the first time that I'm using this. I've read about the syntax, but yeah, this is the first time I'm using it myself. It seems intuitive enough when you get like when you what do you say, when you see it in action, but in these cases I generally prefer to use a struct
Basically,
rather than
the
a tuple.
tuple thing is like it's a more general data structure. Like you can have in your tuple, like even in pairs you can, but like in tuple you can have one and then mix it with strings or float, and within 0 instead of 0 1 2 you can also put the data type, and in that case it will access the element of that data type. Yeah, basically if you want you can read up the docs, they're very nice, but yeah.
Yeah, but acha, like Arpan, I mean,
Yeah.
is there any advantage of using a tuple when things get complicated compared to a struct?
I mean, if it's like as in you if you want to sort, you don't need your like you don't need to define your um,
Acha,
comparator
okay.
in your if you have the
It's
tuple.
gonna
But
refer to the in order thing, right? 1, 2,
yeah,
3.
yeah.
Okay, that's one advantage. Yeah.
And generally like I have experienced this once, but I'm not sure, but like what I believe is these inbuilt functions are working on these data types are faster than anything you can do with your struct, since these are highly optimized. So once I got a TLE with sorting my own struct using a comparator, and it didn't give me a TLE while sorting a pair. So I think it's more optimized, but I'm not 100% sure on that.
Oh, okay. So
And
I'll do one thing. Even I'm not that familiar with Get right now. So I'm sharing the link for the documentation. Even I'm gonna read it after the meet. This thing something new to me too. So but basically like this is a syntax in which you can get, and you can, if you wanted a pair of, the advantage of this thing is when you sort it, it's gonna look at the first value to sort. If the first value comes out to be equal, then it's going to sort it according to the second value. If the first and second values are equal, then it's going to sort according to the third value. You don't have to, if had you declared a custom struct over here, you'd have to declare your own comparator too. We're going to cover that at the end of the session. Any more doubts that I can learn from, or I can teach you?
So this get will work only on tuples, right?
I think it can work on other data structures, so let's try it out. Let me declare, it might not, it may not, it might or it might not. I don't know, I've never encountered it. Let's see. I declare a vector of like integer and it's only 1, 2, 3. I'm gonna see out get the 0th element of where. It doesn't allow me to. I think it works on tuples only then.
Works on tuples, array, pairs, and some others like subrange,
doesn't work.
variant, like yeah.
Yeah,
Again,
it might work on array because and pair and tuple. I think that might be because all of these have a predefined size, right?
yeah, probably so.
Yeah, arrays, pairs, and tuples have a predefined size. Let's try it out with pairs. And p, say p dot ff equals 1. Sorry, second. I'm gonna have it on my Okay, so it works on pairs, yeah. This get function, then it probably works on the data structures that have a predefined size. Arrays, pairs, and tuples have a predefined size. So when you pair has a defined size of 2, tuple it counts when you declare tuple int, right? How many arguments you're passing into this, it calculates the size from that and stores it. And arrays also, you define it like ll comma int comma 3 or something. Yeah, like that. So you declare an array of size 4 like that with an STL. So it works on on the data structures that have a constant size. Yeah. Any more things? After this, I'm gonna move on to I think stacks, queues, and all, and then later on to sets.
There's a question in the chat.
Yeah. Okay, I'll open the chat. Yeah. For auto prefix, slower than using. Okay. It's not exactly slower. If you see, if you're using p, then it's slower. But if you add an ampersand over there, right? If you do it the reference thing, then it won't be slower because it won't create a copy. It will be of the same this thing. It'll take the same time. Auto p will be slower a bit, but if you do auto ampersand p, then it won't be slower. Is that all right?
Okay. Okay, sir. Got it.
Cool. Why is this thing input? Yeah. Yeah. I'll move on to stacks now. So, okay. So you guys probably implemented stacks, queues, and dequeues, as Alpan told me in your DSA course, right? And you used vectors to create stacks. I'm sorry, arrays to create stacks, right? Or linked list.
I think they did it both ways, but I'm not sure.
Both ways. And for queues, they had to use linked list probably.
Yeah.
Okay. So we're gonna start with in stacks, queues, and doubly ended queues. Everything in STL is implemented using vectors. So okay, it's not linked list because linked list, as you might know, they're a bit slower because of the pointer dealing, right? But arrays and vectors, they are a continuous block of memory, so they don't have to deal with pointers to find out what the next element is. So they're a bit faster. And STL uses vectors as a base class for stacks, queues, dequeues. So let's start with stack. You declare it like stack, whatever the data type is. Okay, this can be anything. That's the beauty of C++. So you can, they probably wrote a code once for stack, and then you can pass in integer, float, whatever you want. I can even pass string or a vector. This class of anything. I'm going to be keep it simple. I'm going to keep it simple with integer. So there are two operations on stack that you like to do mainly. That's stack dot push. One. Let's first create a function over here. Void. That's gonna print out my stack because I'm gonna call that function again. I'm gonna print stack int ampersand st. Ampersand is for passing by reference, so that it does not create a copy. For auto x ampersand x int st. What happened? Oh, can I not iterate over this? I'll use iterator.
I think you can. There's. I think passing if the reference is wrong, it's by default it's a reference. Doesn't pass a copy.
Your voice is not clear. Can you repeat it?
I think it is by default passed by reference. It's like array. I think the
No.
ampersand there is
These
not like-
so these are objects. Objects are like they're a wrapper around a basic array, but when you pass it on, it is passed by value. It's not by reference. To add reference, you'll have to use the ampersand sign. It's something similar.
Vectors
So
are passed, but vectors are passed by reference, right?
no, vectors are also not passed by reference. So you remember something? Let me show this thing to you. So make it a bit more intuitive. I can do C. Suppose I declare two vectors. Vec1, which is gonna be 1, 2, 3, and vec2 is also 1, 2, 3. Now, what would have happened in C if I did vec1 equals vec2? What would I have this done? Can you respond? In array in C, this would have been arrays, right?
It would be the base address, right?
Yeah, base address of the array, exactly.
But here, I think there is a overloaded operator.
Yeah,
right?
they're
So we
overloaded
compare-
operator. That's why. Exactly. That's what I'm talking about. So they've overridden it in a similar way. When you pass things, when you pass in a single array, it's passed by it's passed by reference. This thing is passed by reference. But when you pass in a vector, then that thing has been overloaded and it is passed by value.
Thank you.
Yeah, that's it.
Sir, like I have a doubt.
Yeah.
On this overloading thing. Like, what exactly is overloading?
What is overloading?
Yeah.
Okay, so it's something. It's a feature of object-oriented programming. Okay, so suppose you create. Let's see. You create a data structure, something like struct. Let's say point. Okay, and you have int x, int y, int z. All right, and over here you declare point a1 and point a2 with some values, right? These are coordinates in your 3D space, and suppose you want to add these coordinates, right? What would you do? If you want to add these coordinates, you'd have to go manually and do x. You have to manually add the x value, y value, and z value, right? But that would be
Yes.
but that would like we're using computers, so is there a better way for that? So what happens is if you use instead of struct, if you use classes, if you change this to class, then you can actually use an override operator. I forgot the syntax of that, so I can't type it out right now, but you can look it up, and you can override the plus equals operator, like this is an operator in C++, to actually add those individual values over here. Once you do that, while declaring the structure or the class, then you can simply do a1 plus equals a2 and will do it for you. That's operator overloading. So this is one of the operators that I overloaded. I can overload increment operator, then it's going to increase every single value by 1. Decrement equals the equals operator, so vectors internally they're arrays, so equal to operator has been overloaded to check each and every, if I compare two vectors, vec1 equals vec2, so it has been overloaded to check each and every element of the vector using a for loop. So it's mainly for convenience that you do this thing. I can overload these kinds of operators, less than, equal than,
Okay.
like that's basically operator overloading. You define operations for structures. You have operations for integers or floats, but if what we want to define operators for structures, then you do this thing. So where was I? I was at stack. Any more questions before I move on to stacks? No, right? So
Hello,
yeah, okay,
Rahul, right?
yeah.
Yeah, okay. So if we put the vector in the structure like not only integers in x, in y, in z, I will put vector in of a comma vector in of b. So what if I do the plus is equal to them?
Please can you repeat?
Yeah, like if there are integers, you told that it will add the every integers if we do
Yeah,
plus.
yeah, yeah. Okay.
So what if I kept the vector in
If
instead
you
of
put a vector inside, so it's when you do plus equals for, if you have this thing struct. See, I can't show that to you because I forgot the syntax for it. But
yeah,
this
do you
one.
have an idea what it actually do?
So
That's what.
so you're saying if I have a vector int over here
Yeah.
and I do let's say point plus equals something, right?
Yes, yes, yes.
So if internally I have my operator defined for this, so I am the one who's declaring this class. I'm the one who's declaring this struct. So I want people to know that this is like, this would be an absurd operation, right? You can't add vectors. So that operation should not be overloaded. And in that case, if you don't want to do it, suppose this thing, let's say, suppose you have some other struct over here that already has an operator overloading inside it. You can have another struct declaration over here, right? Maybe let's call it coordinate, so coordinate x or something. Then you can from within that operator overloading, you can call in the plus equals operator on the basic data structure inside it, and it's going to refer to the operator overloading of that data structure that's defined.
Yeah, fine, understood.
If you get, I think if that was your what that's what your question was. But if you want to say that uh, since you are the one who is defining this structure over here, and like having a plus equals, that doesn't make sense for vectors. Okay, unless it is something like a coordinate that I was talking about. Cool. I'll move on to stack. So
Nice, nice.
let's, what was that? Yeah, stack. Okay, I can declare a stack. I can push an element one. That's gonna push it to the top of the stack. Right now the stack will be one. Now if I do st dot push two, now it's gonna be one and two. Now if I do cout, how do you find the top element of the stack? You're gonna use the function top. And that's been defined this thing in the stack class. Now it's gonna print it out. If to pop it out from the stack, to remove the element from the top of the stack, I'm gonna do st.pop. This is gonna remove. Now my stack becomes one. Now if I print out the top element of the stack, it should be one. And then I do st.pop. And also let's at the end print out st.size. This should be 0. So 2, 1, and 0. So this was the top element of the stack. After I inserted 1 and 2, then it popped out 2. Then it became only 1. That's the top element. Then this is the size of the stack at the end. So these are mainly the three functions that are like the four functions that are often used in stack. You want to know the stack of the size, sorry, the size of the stack, the top element. You want to pop it from top, and you want to push on top. There are other things also available. You can see if the stack is empty or not using this thing. Let's see. I'm gonna print it out over here. If stack dot empty layout empty. This is another function. Oh, it should be empty. So after I called it this thing, after pushing in one, right? Like after popping off two, but there still was one element over there, so it prints not empty. And then I removed that one element, and then the stack size was 0, and it prints out empty. So these are mainly the functions that you use. Often you'll encounter questions where you have to keep popping. Have you guys encountered? Have you guys solved questions using stack in your DSA course? Urban, have you solved it? The bracket
Yeah.
sequence questions and things like that.
Yeah, they have.
Yeah, so you probably want to in those sort of questions where you have to use bracket sequencing, you can use something like while stack is not empty, not stack.empty, st.pop, and whatever your logic for the program is, you can place it over here. Like that's how you deal with the stack. In a similar way, you deal with queues. You probably encounter a use of queue more than a stack. That's mainly because of the breadth first search algorithm in graph theory. I'm gonna move on to queues now. If stack is clear, anything?
I have a doubt.
Yeah, please.
So there is no direct function to empty the stack, right?
There is stack. There is a function for almost everything. You can call stack.clear. This is the same because there is a clear. Why is it not working? Oh, okay, sorry. For stack, there isn't a function. There is a function for vectors, but that function doesn't work on stack. You'll have to, yeah. Thanks for reminding me about this. I've done this multiple times. It is stack.clear on my code, but it does not work. You'll have to use a while loop for that. That's correct. You'll have to use a while loop if while stack is not empty. Or like while st, I have to do st.size, st.pop. This is how you clear out the stack. st.clear function, like there's a vector.clear function, but that doesn't work on stacks. Why? There should be a reason behind that probably. I think if you look at the documentation, they're gonna tell you what the reason behind it is, but there is no function for that.
Hello.
Yeah.
Is there a way to release the memory without doing all these iterations? I just want to release the memory of the stack. Can I do that?
So if you're okay, yeah, if you declare this thing in a scope, you guys know about scoping, right? If I declare this thing in curly brackets over here, this thing is declared inside a scope. So whenever I'm done with my logic, if I go out of scope, if I go, if my compiler while executing the code, like not compiler, sorry, the program while executing the code, it goes beyond this thing, it loses the scope of the stack and it's automatically cleared out of the memory.
So everything the stack is associated with as well, right? And not just the like whatever the pointer was or something.
Everything associated with stack, yes. Like once you reach over here, it's as if there was no declaration of stack. And whatever, suppose you want to compute something in compute, you do this thing, you do your computation over here, you assign the compute variable, the final answer is equal to 1 after calculating, and then you can print out the answer over here, and this thing is going to go out of stack. But like, what's the use of like whatever is your function call? It's everything is scoped over there. Like, what was the motive behind you asking the question? Can I ask?
I'm thinking more on the lines of dynamic memory. Like when we used to use malloc, we had to explicitly clear it somehow, right?
Yeah, that's the beauty of it. Like all of this thing is actually it clears out vector. It's based on vector. Stacks are based on
You
vector.
can
So
use
vector.
something like delete. So you can do delete object name, and I think it works on all classes. So everything associated to the class will be deleted.
Oh,
Like,
but that is when you that is when you declare it using the new thing, right?
no, like like I mean, I think it works. Wait, can
Okay,
you
does
check?
it? Okay, let me try. You're saying delete state
Yeah, I think it should work, but I'm not sure.
or something like this thing or this thing, something like that.
Oh yeah, you need to do it using new. Yeah, I forgot that. Yeah, yeah.
Yeah, when you assign new. So, but that's with pointers, right?
Mhm.
So
Yeah,
I'm sorry to interrupt
yeah,
again,
yeah, yeah.
but like in the last meet we were also told that under the hood vector is like using mallocs in themselves, right?
Yeah, vector internally is using mallocs. Yes, that's correct.
So suppose like are vectors also cleared out after the scope like
Yes, they are.
automatically?
See, vectors are a class, and every class has a constructor and a destructor. So that's the beauty of C++. When it introduced classes, it introduced a constructor function and a destructor function. Whenever you declare the object, the constructor function is called, and it's the job of the constructor function to allocate the memory. And as soon as that thing goes out of scope, your program when it's compiled, the final program is in such a way that as soon as it goes out of scope, the destructor is called, and it internally destructor has that free function to remove that memory. So
Understood.
if
Thanks.
you want to finally like there will come a time when you'll have to create your own classes. Then you'll have to create a destructor and a constructor function yourself for those things. If you are allocating and deallocating memory.
Do I have to create a destructor, or like is
No,
there
no.
ever a default?
If you're creating your own, like in competitive programming, you won't ever encounter a situation will have to do that. But if you're going using C++ for the kind of programming, if you're writing an application or something, and you don't want to use existing data structures, you want to create your own data structure, some other way to store your own data, then you'll have to use that.
Okay, thanks.
But read up on constructors and destructors. I'm like your question. I know what you're asking, and you're gonna understand from that. Okay.
Hello.
Yeah, yeah, yeah.
Oh, what error you were getting while trying to print the stack via function?
Oh, yeah. That's because stacks cannot be iterated over. I did not know that until now. You cannot
So
iterate over because stacks are designed in a way that you're only meant to look at the top element. You don't know what's below it until and unless you pop the top element. You won't ever come to know what's below it. That's
right, so
why they
that
haven't allowed iterating over it.
right.
Okay. Yeah. Anything else? I'll move on to queues.
So isn't stack made up of vectors also? 'Cause
Yeah,
if it is,
it
then
is internally it is vectors. Yeah.
so if it is vectors, then we should be able to access it, right?
Yeah, we should be able to, but uh, they have not allowed us to because stacks are not meant to be iterated over.
Okay.
So like yeah, it is made up of, even if it is internally made up of something else. The thing is
You
called
can
scoping.
override it again to not allow it.
Yeah, so like these classes will have different that thing in its private scope. So again, in object-oriented programming, like you cannot access anything that is private. So all the data, like it's just not available to us. Like it's there, but yeah.
Yeah, if you want to do that, then it means that you want to use vectors and not stacks. Then you should
Yeah,
use
right.
vectors. Okay.
Yeah, understood.
Okay, I'm moving on to queues. Very similar to stacks. Stack is the first in, what's it? First in, first out. No, first in, last out. Right? First in, last out. Yeah, it's first in, last out, and queues are first in, first out. So similarly, so yeah, I forgot to mention that like this header file includes everything, but if you want to include a stack just like that, you use include stack, and for queue you use queue. Yeah, that's it. So let me declare a queue. Queue I'm going to declare a queue of integers to be simple, but again, you can declare of any kind of queue of strings, queue of vectors, whatever you want to. Let's call it queue. I'm going to push in queue. In a queue, I'm going to push in 1. Now my queue has element 1. I'm going to push in 2. Now my queue has element 1 and 2. I want to push in 3. Now if I print out a stack had the function called top, right? Stack.top, but for queue it's front queue. You want to know what element is there in the front of the queue. So I'm going to print it out. This should print out 1 because 1 is at the front of the queue. And then if I do queue.pop, this should remove the front element of the queue, and that's it should remove 1. Now the elements become 2 and 3. Let's execute this thing now, and then let me print out q dot front again. This should print out 2, right? I guess you are following me. At the end, yeah, let's do it now. Okay. 1 and 2. The output is 1 and 2. The first output was 1 because it was the front element. Then I removed 1 from it, and it printed out the second element. Very similar to stack. It's just the first element that comes in goes out rather than the topmost element, the latest one that you inserted. Again, there are functions like q dot what do you say size and q dot empty to check whether it's empty or not. Very similar to it, just instead of FIFO and LIFO, they both are swapped. And you'll probably be using queues more than stacks because of the BFS algorithm. DFS requires stacks, but rather than stacks, we use recursion. That's your memory stack that you use. That's it. Then it's really similar to stacks. Any questions on queues? If you want to iterate over a queue, you'll probably do something like while not queue.empty. And internally, there would be some operations that would pop in a queue or push into a queue or something like that. Should I move on to dequeues? Okay,
Can we use iterators to iterate over a queue?
No, I don't think you can. That's the same point again. Queues are not meant to be iterated over. You're only meant to look at the first value.
Okay.
If you want to use something, if you want to iterate over it, you should use vectors. I'm going to move on to dequeues, which are a combination of stacks and queues. Have you all implemented dequeues? Have they implemented dequeues? I remember doing it myself. It was a nightmare for me. Oh, okay, using linked list, right? That pointer dealing where the head goes and tail goes. It was sort of okay. Anyway, all of that has been handled by the CL library. Once you write a code, you don't want to rewrite it again, right? So you declare a dequeue using dequeue. I want to declare a dequeue of integers, and let's call it dequeue. Why not? So it allows you to push. It's a doubly ended queue. It's a queue with 2 ends. You can push in from one end and pop it from the same end. You can push in from the left hand side, pop it from the left hand side, right hand side. And let's do it. So currently my queue is empty. Like that. What I want to do is I want to do dequeue dot push. I want to push from back side, that is the right hand side. I want to push the number 100, let's say. Now my dequeue becomes 100. I want to push 200. Now it becomes 200. And if I want to do dequeue dot push front 1, rather than I'll do 2 first, it becomes 2, 100, 200. And if I push 1, it becomes 1, 2, 100, 200. Push from the front side, push from the back end side. Let me print stuff out now. I'm going to print dequeue to access the front element. I'll use this method similar to queues. To access the back element, I'm going to use back. Very similar to vectors. In vectors also you can access the front and the back of a vector using front and back. Okay, and then let's pop it. Dequeue.pop. This time, what I'm going to do, I'm going to pop on the front hand side only. Let's do it a couple of times. 3 times is sufficient, I guess. Yeah. Cool. So what am I doing? Let me iterate it over again. I'm pushing it from the back end side and the front end side, so that my final dequeue is like this. Then I'm printing out the front and back. This should print out 1 and 200. And then I'm popping from the front and printing it. So if I pop once, actually I'm popping it 4 times, and then this should not be there, right? I'll have to remove this thing. Yeah. I can print only 3 times. Yeah, I pop it once. This from the front side, this should remove 1. I should get the output 2. And I pop the 2 again from here using this function call. It should print out 100. And then pop out 100, and this should print out 200. So what should be my output should be 1, 200, and then 2, 100, 200. Let's see. 1, 200, 2, 100, 200. Yes, that's it. Very similar to stack. It's a combination of a stack and queue, or WMD queue. You can push in and pop in from both the sides. You cannot iterate over it because it is what do you say? It's not meant to be that way. It's meant to be in a way that you can only access the ends of it. That's it. Again, you can use .size, empty to find out whether it's empty or not. Any questions? There's one more thing that vectors have a function. I'm going to talk about that now.
Yeah, so like, are there any advantages of using stacks and queue over this? Because it's essentially doing the same, no?
Yeah, I mean, you can solve all the stack questions using a dequeue questions, but it's basically for convenience. You don't want to remember front, back, and all these things, right? If that's the case, you don't want to remember it, you can just immediately use. At the end, you can use vectors also, right? You can use vectors to simulate a dequeue. You can use vectors to simulate a stack. Why don't you use it? It's for convenience. So that you don't have to actually write push front, and you can just use push.
Yeah, so no gains in execution time, right?
No, none at all. It's the same. Everything is the same. So you have a vector. A dequeue is a wrapper around a vector, right? And the stack and a queue are vectors around a dequeue. So first, that's how the level goes. From vector, you go to dequeue. Whatever function you call from a vector, it actually from a stack, it actually refers to dequeue, and then from dequeue it refers to vector and then calls it. And there might be a small performance gain, but that doesn't matter because of the recursion trace. But it doesn't matter. You'd rather want to use a stack just for readability of the code instead of a dequeue, because someone else might view your code and he might think that you're actually using dequeue, which means that you're using both ends of the queue, but the logic requires only one end. So it's better to ensure that your code is readable. Anything else? Also, I remember encountering a question where I had to use 2 dequeues, and often I had to swap them. Like, you can if this goes to anything. If you have vector vec1, you can do vec1 dot swap vec2, or you could do vec2 dot swap vec1. Whatever the data type of this thing is, the data type the left hand side is, the argument should be of the same data type, and this is essentially going to swap the elements of the two vectors in an order of an operation. It basically changes the pointers of that. So you might encounter some places where to make your code like to code something fast, you'll have to probably use this thing. Like I'm just saying this thing because I had encountered a situation where I had to use this thing in a logic. I had to swap two vectors. And actually it was dequeues that I had to swap. So vectors had this function swap. The same thing you can use for stacks, queues, and dequeues. It follows on. You can swap to dequeues. If I find that problem, I'll probably give a link for it in the Discord server.
There's
That's
a
it.
question in the chat. I think.
Oh, okay, chat. Sorry, what is meant by wrapper? Wrapper on a vector. So you've got a class, right? In wrapper. So in object-oriented programming, you have classes, and then from classes you can actually derive more classes, the subclasses. That's essentially what I mean by a wrapper. So how do I explain this thing? So you wrapper. It's like but it's quite literally a wrapper, right? Like a chocolate wrapper. You have it like that. That's what I meant by literal sense. But there's a class for vectors declared somewhere. What's the advantage of using a wrapper? I'm telling you that there's a class of stack declared. Sorry, a class of vectors declared with all the functions. Then you realize that you want a separate class for a stack too. And but the thing is, the stacks can be implemented using vectors, and most of the functions of a stack, your size, empty, and all these things, many of the functions are common. So you don't want to rewrite the code again, right? For that thing, it's better to inherit some properties from the main class, right? So that's why you derive your another class, that's your stack class, from your main vector class. That's essentially what I mean by wrapper. I hope that clears.
Yeah, so if you're familiar with object-oriented programming terminology, it's like basically encapsulation. Like it tries to provide further uses of the class inside by like it makes it easier to access certain functionalities of the class inside.
It's an encapsulation and inheritance too.
Yeah.
That's something that's the gift of object-oriented programming. I hope that clarifies it. I'm gonna start with priority queues now. Hopefully we'll finish this thing by 8. Let's see. 7:22 right now. I'm gonna start talking about priority queues in case there is any question. You'll have to interrupt me right now.
Could you repeat the part that you said about like scope, how you could make some object go out of scope at will?
I didn't catch my question. Could you repeat it?
So normally we can't control when an object goes out of scope, right?
Yeah.
You have to wait till it actually goes out of scope, like an if or function or something.
Yeah, that's how you control it.
So we can't manually decide. Okay, because it's a stack you can't do.
In the sense, see, if you want to explicitly want it to immediately go out of scope, see, these small things are not going to create like memory issues for you all. Like C++ handles that very efficiently. But if you want to explicitly do that, then you can use the curly braces notation to declare a specific scope just for this purpose. However, as soon as the function ends, that thing automatically goes out of scope and that memory is cleared up.
Got it. Thanks.
Okay, cool. I'll start with priority queues. Oh, okay. Priority queues, like you guys probably implemented binary heaps, right? Min max heaps. Priority queues, priority queues, what are they? you've got a data structure, a huge chunk of data. At one point of time, it's like a queue. It's like a queue, but you want to access the maximum element of the queue only. You insert into the queue a lot of elements, but when you want to pop something from an element, as soon as like you want to quickly pop off the element which is the least, or element which is the most, the greatest element of it. That's a priority queue. You guys probably implemented binary heaps, and binary heaps priority queues, like priority queues can be implemented using binary heaps, but SCL doesn't use binary heaps. Internally, it uses Fibonacci heaps, which even I don't know what they are. I haven't read about them, but they're supposed to be faster than binary heaps. The logic is very similar among them. So I'll show you a priority queue in action. So let's see, PQ dot push. We want to push is used to insert in the priority queue. I want to insert one. Let me insert. Let's see. I'm going to insert 2, 3, 4, 5. Let me change the order. Just like that, shuffle it around. And now I want to see out PQ dot what's it? Front? No, it's top. It's top. Which element is the top of my queue? It outputs 5, which is the greatest element of my queue. Okay. This, so essentially it's a max heap. You can imagine it to be a max heap. Heaps internally. And this operations, your push operation is log n time. Like in dequeues or in stacks or in queues, it was order of runtime, right? But over here it's log n time. And your this top operation is O of runtime. Do you guys remember like how binary heaps behave? It's you have this huge array where the elements at multiples of 2, like 2 and then 3, and then 2 into I, 2 into I plus 1, thing like that. And then you insert at the bottom of it and then glides to the top. Someone is unmuted. Is there a doubt?
So the push operation in the stacks, queues, and dequeues is O of 1, right?
The insert operation stacks and dequeues and queues are O of 1, but in priority queue it's O of log n to insert. But to get the top element, it's O of runtime, and to what you say, if you now remove the first element, the top element from the queue, priority queue, it's gonna be pop. This is gonna take log n time again, because it has to rearrange the entire binary heap. If you guys remember, like
Sir,
yeah,
this login and O of 1, this is the same as binary heaps, right?
yeah, it is the same as binary heaps. Internally, it is binary heap only. Like it's Fibonacci heap, which is very similar to binary heap.
Yeah, so like, shouldn't there be a time gain?
Time gain.
Like, shouldn't it take less time because it's a different data structure, faster one?
The time gain is actually in the constant complexity that is multiplied with log n.
Oh, okay.
Not in the, that's why they use Fibonacci, not in the actual complexity. It's in the constant that's
Even
multiplied with the real time complexity, whatever it's called.
even otherwise, programs with the same time complexity need not be equally fast, right?
Yeah, it depends on the computer, it depends on various factors. It depends on how many operations you do, like the constant operations. In Fibonacci heaps, the constant operations are less. That's why it's faster. That's what I read. I haven't read Fibonacci heaps in detail and how they work. But the complexity, in terms of n, the complexity is same. You can pop in then the function pq dot size, pq dot empty to check whether it's empty or not. Now, if you like, this is what is it? It's gonna give you only the maximum element. What if you want the minimum element? There's a different syntax for minimum priority queue. And one second. Cool. I have to look up the syntax. You'll find the syntax is really weird because that's the reason I forget it every time. Oh yeah, this is a syntax for minimum queue, minimum priority queue. And if I do pq.push 1 and 2, 3, 4, 5, or we do this split it around, and if I output pq.top, it should output 1, that is the least element. So this is our minimum binary. So what's the uses of, or like what when is this thing used? Priority queue. Like sometimes there are questions, some problems which revolve around priority queues. Like the logic of it revolves around priority queues. You'll have to use it then. And in algorithms, you'll probably be using this thing in Dijkstra's algorithm in graph theory. That's one place that it's always used. And also in Kruskal's algorithm, sometimes some people use sorting, some people use priority queues. It's up to you. It's a matter of personal preference. Yeah, and sometimes there are questions which often revolve around this property that you have to, given the set of elements, you have to quickly find out the minimum or the maximum element. Then in that case, your priority queue is the way to go. This is the syntax for declaring and using priority queues and the functions of it. Like I'll stop this thing and move on to iterators and sets and maps now. If anyone has a question, they can ask right now.
Yeah, so there's a question in chat. So
Okay.
what is the second argument for?
Yeah, I don't know about that. Sorry about that, but I've never looked it up.
Yeah,
Maybe
so
you can. Do you know, Arpan?
something-
Because I don't. I never bothered.
Yeah,
to
I
look
don't know exactly, but it's something called a container. So by default, this container is a vector. Like if I when you were doing the math sheet, it's something like priority queue int, and by default, it's vector int, and which is why you don't need to declare it then. So, but when you are changing the comparator, you always need to provide the second argument, which is why this comes in by default. But
Okay.
what,
So this
what
greater int
yeah.
is this is the comparator, and this thing. Why do you have to redefine the container again once you are declaring the comparator?
Yeah, so by default it is this itself, but like if you want to change the third default argument, you have to mention the second argument. I mean, by C++ logic.
Oh.
So
Okay.
so that's why you need to put this vector in. But what the comparator does, the container does exactly is like it's like, you know, where internally the elements uh, of this data structure is stored. So I don't know what exactly could be used instead of this, but like that's the idea, that internally it stores all your things somewhere, right? So uh, it's yeah, so internally it's just storing
What exactly is
all the
greater?
elements.
Yeah. So what exactly? There's another question. What exactly is greater int? That's actually telling you to use. Like I'm gonna cover comparators later on, and it tells you to use the greater comparator, which is like the opposite of the default lesser comparator that's used. So it basically reverses it. In sorting also, you would have realized sometimes that if you want to reverse sort it, either you can sort it and then reverse it, or you can sort it and pass in the greater argument, like greater int argument that changes the comparator. It basically tells it to reverse the operation. Yeah.
Also, what is the difference between emplace and push function?
Okay. Push function takes in only one argument, and let me try using vector. Suppose I have vector of pairs. So what I want to do is if I want to push in a vector, sorry, in a pair, I'm going to do vec dot push 1 comma 2, right? I have to use this curly bracket notation. What happened? Push back, sorry. Yeah, push back 1 comma 2. This curly bracket notation to like construct whatever the data structure that it's accepting. And it because pushback only takes in one argument. But what I can do also do is I can use vec dot emplace back. Emplace back is supposed to be much faster, and you can pass in 1 comma 2 as it is. You can take in multiple arguments. How it works is that it looks it up internally. See, whatever it is, it assumes that you know what you're doing. That's why it assumes that you know that what you know is that you've declared a pair of integers as a data type. So it's going to be only 2 chunks of integers and nothing else. It's in stored. How is this thing stored in memory? So if you have this thing 1 comma 2 3 comma 4 internally in memory, it is stored exactly as 1 2 3 and 4 contiguously. And so once you do emplace back, it takes this block 1 comma 2 and places it directly in memory like that. If you do right now, it's going to place it 1 2 directly as it is inside it. When you do pushback, it will create a pair out of it, and it will look at what pair internally does. Pair internally stores it side by side, then it will store it side by side again. Like it will look at pair stored side by side, and that's why it will store side by side in the memory. But if you use emplace back, it's going to store it as it is. It assumes that you know how pair internally stores, and you're following the same mechanism. I talked a lot of things. I hope you understood it. If not, I can explain it again.
Can we have multiple arguments in the emplace back?
Yeah, you can have multiple arguments, and it's gonna place it as it is in the order of the arguments. It's gonna place it as it is in the memory.
Okay.
That's why it's much faster, but it's kind of riskier also if you don't know what you're doing, because it can.
How are we able to have multiple arguments, like variable number of arguments?
That's allowed in C++. Like in I think every programming language allows that nowadays. Right? Even C allows that. In C, you could have. You had printf, right, and you passed in a string, and you have percentage d and all. So depending on the percentage d, you had multiple arguments over here. Every programming language allows that. You have a syntax for that. I think it's something using star and something else. Like there's a syntax for that.
That is in Python. Here we have dot dot dot.
Oh, here dot dot dot. Oh, okay. So there's a syntax for that. For these things, I always have to look them up, but you can have multiple arguments, and those arguments are stored as sort of array, and you have to iterate over it and find out individual arguments when you're declaring the function. Okay.
So emplace back has a better significance in case of vector of vectors or vector of pairs, right?
So vector of that's the thing. When you use vector of vectors, how is it gonna work? I'm not sure. You have to look up the documentation of emplace back, because why is that? Suppose I have a vector of vectors. What is it gonna do? Is it gonna place 1 comma 2 in the same vector, in the first vector, or is it gonna place the first element in the first vector, second element in the second vector? It doesn't know, right? That creates kind of a problem. So for that, you have to look up the documentation of emplace back, what actually it does.
Wait, I don't. That is not what emplace back does.
Oh, is
Like,
it?
yeah, emplace back just provides basically emplace back. Like instead of constructing the object by calling the constructor and then
Yeah.
passing the object to pushback, you can directly pass the constructor arguments to emplace back, and it will do the construction plus insertion like in one step, which basically saves you like move time. If you build a pair and then give it to it, and then it will push back the pair, that's like too much, like double work. So it just avoids you from doing like 2 steps. So whatever arguments you provide to emplace back, they have to be valid constructor arguments to the whatever like vector element you have. For example, for pair,
pair has two constructors. One that doesn't take any arguments and just builds okay, actually pair has two constructors. I think the default one that doesn't take any arguments and defaults the two elements in it. And the other, it takes two values and builds like a pair out of it. So pair has you can either pass I think you can just say implies back and it should compile if I remember correctly. And similarly, vector has few constructors. First constructor is you don't say anything, it'll make an empty vector. If you pass just one number, it'll take that to be the size. If you pass two numbers, two values, the first is the size and the second is the default value. So if we say vector of 5 comma x, then it will make a vector of size 5. Yeah. So that will the second one. I don't know why the first one got underlined. Oh, yeah, name clash. Yeah. So the second one is a vector of size 2. That if you do this, this is using an initializer list. That is, you can pass a list and it will initialize the vector to that elements. So these are the valid containers for. These are valid constructors for vector. When you do place back, you can pass these arguments as is instead of building a vector and then passing the arguments, which is just saves I mean, in most cases the compiler actually does the optimization for you, but yeah, it still saves code also, because you don't have to build a vector and then do pushback. You can directly, if you can call a constructor, you can directly call it using mplaceback. So yeah, it doesn't change any semantics with respect to pushback. It just saves you an unnecessary temporary construction of whatever variable you're.
I hope Anirudh sir clarified that thing for you guys.
No.
All right. Where was I? So should I get over with priority queues and move on to iterators and sets and maps? So I'll do that. I introduced iterators beforehand. I hope you're I'm gonna move further. One thing I didn't introduce was reverse iterators. So if I have vector, any container, let's say and how did you iterate it using proper iterators? Was using auto it equals vec dot begin, it not equals vec dot end, it plus plus, and you outputted the dereference of it, right? Because iterators behave like pointers. But if you want to reverse, if you want to iterate in the reverse order, then there also are functions called you have these reverse iterators r begin it not equals to r1 it plus plus cout. So what happened? So essentially you've got this array, right? Let's see. So your vec dot begin pointed at the first element and vec dot end pointed towards the space right after the last element. What r begin does is r begin points towards the left, the last element, and r end points towards the space right before the beginning of the vector. So you can iterate it from this thing over 3, from 3 to the first way. And I think this has been overridden in the plus plus operator to iterate in the backward direction. Let me test that once again. I'm not sure. Let me find out. 1 2 3 t 2 1. Yeah. The plus plus operator for reverse iterators has been overridden, so that it iterates, it actually decrements internally rather than incrementing. That's for reverse iterators. So if you want to iterate in the opposite direction. So also I had introduced this fancy new recent notation. I don't know the name of the notation, but you can use x to iterate over and print out x. This is basically the same as the first loop over here. Okay. I'm going to move to sets, but sets is going to use a lot of things from iterators. That's why I recapped over it, whatever I had explained before. So basically, you want a data structure that performs efficient insertion, deletion, and searching. Right, vectors you can insert in order of one time, but deletion and searching might take order of n time depending on where your element is. You can't do an in a vector in a list, that's you can't do, the structure is unordered, so you can't do a binary search. And the solution for that is binary search trees. You guys have studied that already, and I think Arpan, did they implement ABL trees?
Yeah, they have had an introduction. I don't think they implemented.
Oh, you did not. Okay, never mind. But yeah, it doesn't matter. But you guys have an idea of how they work, right? The balancing and
Yeah,
all those
that's
things.
it.
So essentially, red-black trees are similar to AVL trees. So there are some minor differences. Not minor. There are differences, but the essence is the same. They also work on balancing the left and the right hand side. So all of that has been provided to you as a class in C++ in SQL library, and you can call them like set is the name of the class. So you can declare a binary search tree of integers using set s, and it's quite literally a set as in a mathematical set similar to that, because it allows you only one instance of an element. So if you insert something multiple times, it doesn't allow you it stores only one instance of that variable of that integer. So if I do to insert, I'm going to use, instead of pushback, I'm going to use insert 0. Let me insert 1, 5, and 6. So I've inserted this. Insert operation in a binary search tree takes log n amount of time. And for printing this thing out, I'm going to do auto it equals s dot begin, it not equals s dot end, it plus plus, and I'm gonna output the re-reference of it. Over here, you cannot use for int I equals 0, I less than n, or something 5, I plus plus cout si, because sets cannot be indexed like this thing, like arrays, because they're not stored in a contiguous block of memory. So index operation is not valid for them. So you cannot do this thing. For this thing, to get the element to iterate over them, you'll have to use the iterators. And rather than doing this, I can like use the new fancy notation of auto x in it, sorry, not it, in s. That's my set. I can just see out x. This is the same thing as this thing, except for the fact it's creating a copy. Look at the order in which prints out 0, 5, 0, 1, 5, 6. Is it the same order in which I inserted? I should have changed this thing. I'm going to change this thing. The new order is 5601. But when I print it out, it's going to print it out in 0516 order only. That's the sorted order, because when I iterate over a binary search tree, it's iterating from the left hand side to the right hand side. If you have a binary search tree, it's going to the leftmost node, and then from there it's starting off to iterate, and then like that's where the s dot begin points to, and s dot end points to the rightmost node of the binary search tree, and then from there it traverses by going to the parent and children and all of the elements in between to print in a sorted order. You can delete from this data structure using s dot erase. If I can erase 5, and then let me create a function called print set.
Yes, there are no repeats in set, like multiple.
Yeah, for that there's multiset. I'm gonna talk about that. If I do print set, yes. So I get 0, 1, 6 only. It removes 5 from it. Again, there's another way to erase. You can actually, instead of passing on the argument as an integer or whatever the data type is, you can pass in the iterator that you want, the iterator of the element that you want to erase. So I can pass in s dot begin, and what they should do is should remove the zero with like element. That's the first. That's the leftmost element, and remove it. I can pass in s dot begin and then plus plus of it. That's one more than the s dot begin. And that remove the first element. So internally, there are two variations of the functions implemented, one using the data type that's being declared and one using iterators. And you can use both of them to erase. Insertion, deletion, then you can use search. It's s dot find. You can find for something. Or let's say I'm gonna find 3. Wait, what? Oh, okay, I'm not trying. Okay. What find does it? Find returns to iterator of the object of the element that it's found. So if I do auto it equals s dot find, let's say 1. This could be a huge list. So the searching is going to be on a binary search tree, which is going to take log n time. So this is very efficient searching. Compare that to an unordered list that you have. It's going to search. Let me print it out. So it returns the iterator to the element in the binary search tree that I was looking for. The reference of IT, I'm going to print it out. It's going to print out 1 for me. And in case that element does not exist, 6 exists. If I do 100, 1 does 10, whatever it is, it's gonna point. It's gonna return r dot begin. Sorry, r dot end. It's gonna point towards the element, like whatever the end of the container plus 1, right? That's to tell that the element was not found over there. It's way to say. Then I'll have to. So every time you do s dot find, you need to have a check to see whether it is equals to s dot end or not. In case it is not equal, you'll have to do whatever you want to do. Over here, just type out element not found, else element found. So every time you have this find operation, you'll have to have this check, because it may be possible that the element is not there, right? In that case, it's going to point towards the end of the set. Element is not found. Okay. Then there are functions called lower bound and upper bound. So what are these functions for? Let's see that you have this. What does the set in a sorted? If I write out the set in sorted order, right now it looks like 1, 0, 5, and 6, right? And essentially, I want a binary search for an element. Let's insert this thing. For simplicity, let's say 5. Suppose it's, I want to binary search in the set for an element that's just greater than. Oh, I made a mistake. This should be 0 and this should be 1. Sorry. That's just greater than 2. Let's suppose I want to find an element that's just greater than 2. In an array, suppose you had a sorted array, you would write binary search for that, right? And see if my current element is less than 1, then probably in the right hand side the answer is there. And using divide and conquer, the function lower bound does the same for you. It finds out for you the element which is just greater than your argument. Or in case it's equal, then like just greater than or equal to, that's what it finds. So I'm gonna do s dot lower bound. If I go for 5, over here instead of element of count, I'm just gonna print the difference of it. I'm doing it equals s dot lower bound find. It returns 5 because 5 was found. But what if I do 4? Then also it's going to return 5 because it looks for the element that's just greater than or equal to 4, the next element. In a similar way, upper bound, it looks for element less than that element. So if you pass in 6 over here, it's going to return 6, but if you pass in 7, something like that, it's going to go in element not found case. Because the end of the element is the last element is 6 and there is no element that's greater than or equal to 7. That means do lower bound. Sorry, upper bound. 4. It returns 5. Upper bound returns 5. So what was the function of upper bound? Lower bound. Yeah, if I remember correctly, upper bound looked for element just greater than it. Let me just verify that. It's been a while. Yeah, it returns an element that is just greater than it. So right now it's gonna return the same thing, but if I pass in 5, it should return 6 because it doesn't allow me to. It doesn't have the equality condition. So this might not seem that useful upper bound in the case of sets, but in case of multisets, it's gonna be useful. And in case like I'm gonna cover that later. So essentially, find, upper bound and lower bound are the 3 functions that you can use to binary search over a set. You can experiment further with upper bound and lower bound to get more familiar with it.
You can also use this for vectors.
Yeah,
so lower
but,
bound and upper bound also work for vectors.
But the condition is that the vector has to be sorted and then it will work.
Yeah. So in place of binary search, like you'll often need to use lower bound and upper bound even in vectors.
Yeah, if you don't want to implement binary search yourself, or if it's a simple binary search, then you can use lower bound and upper bound function in vectors also. But that won't be a vec dot upper bound. Okay, it will be like sort. It will be upper bound, and then you'll have to pass in the iterators vector begin, vector end, and then your element, whatever you want to search for. The syntax is different because it's not declared in the namespace of the vector. It's not a method related to the vector class. So, but remember, don't use this thing. S dot begin, S dot end. For sets, if you use this thing, it's gonna probably give you a TLE or something because okay. Because for sets, the method has been separately implemented inside the class. But if for this thing, I think internally it uses it tries to use the contiguous property of the iterators, but it doesn't find it. So it defaults to like manually adding, but like the contiguous property of iterators is not valid for sets, right? So it defaults to incrementing it manually plus 1 by 1. So that's going to give you a TLE. So for sets, don't use this thing. Use S dot upper bound instead of upper bound and then pass in the iterators. But for vectors, it's going to be there. That's if you want to do binary search on vectors. And for sets, you can use these 3 functions. Like you'll have to work around. Like I have some problems. I'm gonna share the link to that. They'll probably use binary search property of sets. you can use that to get familiar with them. Any questions? Then otherwise I'll move on. One more thing is that you can of course use other functions like s.empty to check whether it's empty or not. You can use s.size to find out the size of the set. You can use s.clear to clear all the elements of the set. It's gonna free up the memory. Like you can use s.swap to swap it with another set that's existing. You can declare a set of strings.
Rahul, yeah, so there is a question in the chat that can we do the pre-order or post-order traversal in the set? I thought it's important, so I asked that.
Pre-order traversal, that was the one second. I'll have to draw a diagram for this. 1 second.
You do that actually. I don't.
Yeah, so if I had a set, let me remember what pre-order traversal was.
It will give the inner.
Oh, it was like before going left, I print out the element and then go left, right?
Yeah, but the set will the sets permit that? So we will have the beginning element to the leftmost pointer, and we will not have the root pointer, right? Like
no, for sets, s dot begin always points to the leftmost element. That cannot be changed.
Yeah, so can it be possible to do the pre-order and pre-order and post-order traversals?
That I have to look it up whether the option is available or not. But you can't change the value of the iterator. It can't you can't use s dot begin and s dot end and iterate over it in some way by doing some IT++ or some operation so that it does a pre-order traversal for you. That won't be possible.
Yeah, fine.
But if there is some other method to do it, that probably I'll have to look it up, or you'll have to look it up.
Yeah. So there is no inbuilt function for that.
Hello.
Yeah.
Yeah. So I was a little confused in this lower bound.
Yeah.
So actually both are printing 5, right? So what is lower bound supposed to do?
See, upper bound looks for an element. Whatever you pass in the argument, it looks for the first element that is greater than equal to your argument. Okay. And upper bound looks for greater than argument.
Right. So this lower bound looks for greater than equal to, and upper bound looks for only greater than.
Yeah.
Right.
Is that it, right? I often get confused between these two things. If you can confirm it.
Yeah. So do I. I think it is that.
Yeah.
And can you tell the time complexity of these operations? Insert and
yeah, insert is like it's a binary search tree. So insert and erase, they are order of log n. Be it erase of your whatever, you can pass in whatever it is, like the number or the iterator. And searching is also log n. It's binary search, right? Binary search tree. Everything is log in binary search trees.
Yeah. So upper bound is correct, but lower bound is a bit different. Lower bound is the first element which is greater than greater than equal to argument. So
yeah, that's what I wrote.
Yeah. So it's like not the wait. Yeah. That's what you. Yeah, I forgot.
This is it, right? It's going to return a result which is just greater than equal to argument for lower.
Yeah, so I think there's a small catch with first element and last element. I keep forgetting that way. Upper bound is the last element, which is.
In case it doesn't find it, it's gonna return the last element always. That's one thing.
Yeah. Anyway, I think this is correct.
Yeah, this is it. Lower bound looks for the result which is just greater than equal to the argument. If your argument is already present in the set, then it's return that argument itself. And upper bound, it ensures that even if that argument is present, it's going to return the element after that argument. Okay. It's going to get much more clear in multisets that I'm going to cover next. We're already past 8. It's going to go up to 8:30. So I hope you are sticking around. because I have to cover maps too, and then custom comparators too. Let me check. Okay.
Do we have like a opposite function of the lower bound, like which is less than the argument?
Let's run the argument. See, for that, which is just like the argument. There are tricks for that. You can actually use upper bound and lower bound to simulate all the other functions. That's why they have created this weird kind of pair. So in case of you want something just less than 5, right? So
Yeah, it will be
if you pass in
lower
upper
bound
bound of value -1. So it's on the upper bound of value -1. You're saying that you want the element just less than 5.
Yeah, like which is just opposite of lower bound, like less than or equal to the.
Yeah,
In that case, what you do is you'll find lower bound of 5, lower bound, and it's gonna return the iterator. And then you can do later on you can do -it to get the element just before that. Did you get it? Lower bound and upper bound together can solve all these problems that you have in mind. Some combination of it. Sometimes it is you have to pass in value -1 or something. Like this is the way to get your answer.
Yeah. Okay.
Okay. Cool. I'll move on to multisets. So let me change this thing. Multisets are basically sets, but they allow you to have multiple instances. So I can actually have 5 multiple instead of 5, multiple instead of 6. And let me print out print set then s. There I have multiple instances of things. And the thing is, if I erase an element, it's actually gonna erase all the instances of that element. That's one thing. That's how it's been implemented. So what I'm doing, I'm gonna erase 6. What I should get is all elements of 6 have been erased, all instances. So I get 0, 1, 5, 5. What if I want to erase only one particular instance? Then in that case, I have to pass in the iterator of that particular value. So what I'll do is that I'll check that I want to erase 6, and in case that element does not exist, then it doesn't do anything. Okay, and I have to do s dot find 6. What is? Oh, sorry. Oops, my bad. S dot find 6. What this is gonna do is s dot find 6 is gonna search for for the element 6, right? Occurrence of 6, and it's gonna create an iterator to the first occurrence of 6, and then I'm passing in that iterator. So when I pass in the iterator, it just removes it. It doesn't search, because if I pass in s dot erase 6, it's actually internally it is looking for all the iterators of 6 and then removing them. But if I just pass in the iterator, it's going to remove that only single iterator. It's not going to bother with looking up for similar iterators or something like that. So this is going to remove only one instance of 6. Yeah, and there is one of them. That's how you deal with multi-set insertions and deletions. Again, log n for both, and pretty similar to set red-black trees internally, which are similar to AVL trees. And let's do searching on them, lower bound and upper bound. So let me print out lower bound of 5, and this is s dot lower bound. What lower bound does is it returns an element just greater than or equal to it, right? It returns 5 because 5 is present over there. If I search for 4, it is also going to return 4. It's going to return 5. Essentially, like the first iterator. It's which 5 is that? It's the first 5, the 5 which is the leftmost 5. Okay. And same was the case when I passed in the argument 4. And if I pass in upper bound of 6, sorry, of 5. In that case, when my set was only 0, 5, 1, 6, it would have pointed, it would have looked for the first occurrence of 5, and then I'm looking for the element just greater than 5, right? That's what upper bound does for me. It looks for 5, and the element just after that 6 it prints it out. But in multiset, there are multiple instances of 5, right? This is where it is different. So it looks for the last occurrence of that element 5, like and then prints out the element after that. It doesn't print out this middle 5 because it doesn't look for the first one. It looks for element greater than 5 and prints it out. So when I was talking about that, you can simulate anything using upper bound and multiple lower bound, right? You want to search for something just less than, just greater than equal to, less than equal to. You want to look in a sorted array. You want to look for an element, like these kind of searches. Everything can be done with binary search. These two binary searches. So over there, you'll have to be careful about that because sometimes you might want something less than 6. The first pointer to something less than 6, and it's going to be like 5 over here, just immediately 5. But sometimes you might want to go all the way up to the first element 5. So you'll have to be a bit careful about that part. Otherwise, it's the same as sets. That's it. That's it for multisets. The only difference is, again, like multiple instances are possible. Upper bound and lower bound behave a bit differently than sets.
Also, in erasing in multisets is a bit like, so if you write if I write s dot erase 6 here, it will erase all instances of 6. So if you want to erase a single instance of a 6, you want to do s dot erase and the pointer to that 6.
I thought about that, right? Did I forget? Did I talk about? I think I talked.
Oh, you did? Okay.
Yeah.
I get it.
I did, right? No. Yeah, I think I did. Okay, I think I did. Any doubts about multisets? Else I'll move on to maps, which
These are
like,
real trees, right?
These are not AVL. These are red black trees.
Okay, and the time complexity of these?
Again, login for everything, for searching, for inserting, for deleting.
Right. Thanks.
But mind that if you pass in this s dot erase 6, right, it's going to remove every instance of 6, right? So that won't be like login anymore. It's going to be login into the number of occurrences of 6.
Yes.
All right. Cool. Any other questions? I'll move on to maps. Okay, then let's move on to maps. Maps are like one of the best data structures. Essentially, what is a map? Map is a set of pairs. Right? It's a set of pairs, but it has some additional features that have been given to you, or that is the indexing feature. So you know about key value pairs, right? The key value and then JSON. There are key value pairs in JSON, in Python dictionaries, JavaScript dictionaries. Like they're really useful. So what you want to do is you want to create a mapping between a set of like you have suppose two sets a set on left hand side and right hand side, a set of numbers or anything. This can be like over here I have integers, you can have string or something else. You want to create a mapping from the first one to a second one, a one-to-one map. In that case, how do you store it? Suppose you want to create a map between let's say string and integer, or integer. Let's say integer. Yeah. In what cases would you like to do this thing? Let's talk about that. Suppose in case it is given to you that this is the thing that I'm talking about is called coordinate compression. It's given to you that there's going to be some input, and the range of the input is from 0 to 10 to the power 9. but the number of inputs is going to be 1 to 10 to the power 6. In that case, what you want to do is you want to perform some operations. You want to kind of declare an array of size 1 to 2 to the power 1. You want to suppose calculate the frequency of elements of you want to how do I explain this thing? Suppose you want frequency of numbers. You want to store the frequency of numbers. That's only one example that I'm talking about. You ideally you create a frequency array for that, right? But your numbers they can be till the range of 10 to the power 10, 10 to the power 11, 12. You can't declare an array of that huge of size. But you know that most of the elements in the array are gonna be 0. The frequency of most of the elements are gonna be 0. But the range of numbers is so huge that I can't create an array for that. In that case, you can use maps or sets. What you can do is you can store a pair of integers in your set. Where the first thing is in your pair, the first one is going to be your element for which you want to store the frequency, and the second is going to be the frequency of the element that you want to store. So suppose I get the input 5. I insert for the first time. I insert into the set the pair 5, 1, right? Now, what I want to do is I get another 5 and I want to increase the frequency of 5. In that case, what I want to do is I want to find I'm going to find a pair whose first element is 5 in the set. I'm going to remove that pair from the set, and I'm going to include put 5, 2 in the set, right? Are you guys following me? Like till now, am I clear, Arpan?
Can you not just like modify the frequency only apart from removing the element itself?
Yeah, you can do that. Yeah, of course you can do that too, but you can't directly change an element in the set, right? If you do that, it's gonna remove it and place it again only, because it's gonna change the order of the set, order of elements. It might, if you edit an element in the set, it might change the you essentially changing the value of the set, right? So it has to rearrange it so that the property of binary search tree is valid, that the left hand side has to be less than the right hand side.
So the rearrangement, does it not consider only one index, only one of the values in the pair, or do both the values of the pair somehow matter?
So if you're storing a pair of sets, right, it looks at the first value. If it sorts by the first value, if the first value is the same, then it looks at the second value. That's the order. So for any in the binary search tree, if you're looking at any node, and when you say the left node is less than the right node, then you're essentially talking that the first element of the left node is less than the second element of the right node. And in case the first element of the left node is equal to the second element of the right node, then I am sure that the second element of the left node is less than the second element of the right node. So it's sort by the first element first, and then you look at the second element in case the first element are the same. So like this is how we store in the frequency of huge elements. But this thing, like instead of set of pairs, we use maps. Map is a wrapper around a set of pairs, you could say. I declare it using this syntax MP. What it does is that it gives me the advantage of indexing. So instead of what I would have done over here was s.insert a pair of elements, that's 4, 5. I can actually over here say MP4 equals to 5. The indexing operator has been overwritten to refer to the first element of the pair, and whatever is on the right hand side is stored in the second element of the pair. That is map. It's basically a pair of sets with this additional feature given to you, that you can use this convenient operation, index operator, to assign values.
Hypothetically, we could map anything to anything, right? In the declaration when we're doing.
Yeah, you can use strings over here.
What if I use a string on the left?
You can use string on the left too. What if you want to calculate the frequency of strings, like how many which string occurs multiple, like how many times, then you can use. Yeah. I'll name my string str for the CPP for C++. Yeah, 5. And I can do not only assignment operator, I can use the plus plus increment operator too. What it's gonna do internally, it's gonna see MP is equal to 5 CPP. It's gonna remove that pair. It's gonna store that pair locally. It's gonna increase the second value of the pair by 1, and it's gonna reinsert into the set. That's what it does internally. But for you, if you use map rather than a set of pairs, it gives you this convenient method of doing using this plus plus operator. And how is it true? Because let's see. Essentially, let's iterate over this. How do you iterate over this thing? I can do auto p in MP to prove it that it's a set of pairs. I can do mp print cout mp dot ff. Oh, so, not ff. This is the first.
P dot first, right?
Oh yeah, sorry, my bad. Yeah, P dot first. So first is the CPP, that's the pair, and like the first element of the pair, and second is the second element of the pair. That will be the frequency or whatever you're storing in the second value. So frequency is just an example. You can use it for various other things. I think frequency is the simplest example from it. You can understand it. So essentially, it is internally this thing only, a set of pairs, but you can use these additional features. So I can, how do I find if an element is already like I can use again, I can use features like find and all. So I can do if auto id equals mp dot find CPP. Let's say CPP. Let me check. This does not work. Maybe yeah. What I did over here was, it is a set of pairs, that's true, but for finding you can just use the first element of the pair. If had you been using a set of pairs, then you'd have to pass in a pair into this find function, right? Because it expects you to find the pair, because pass in a pair because it has been declared a set of pairs. But over here, this function has been overridden so that you can only find the you can pass in the first element of the pair to search for it. It assumes that it assumes that you have only one occurrence of CPP in it if you have one, and that has been mapped to something. Because it is a set, it's not a multi-set internally. You can't have internally you can't have two elements like CPP comma 5 and CPP comma 6. No, if you insert CPP comma 6, CPP 5 will be overwritten, and 6 will be inserted in place of that. Both of them can't exist at the same time because it is a set of pairs, not a multi-set. That's it. But maps are really powerful. You can use it to store frequency of a huge numbers. You can store it. You can use it to compress numbers. You can, like, suppose you don't want your numbers are huge, from ranging till 1 to the power 80, but the size of your input is only 10 to the power 5. Then you can map those numbers to the range 0 to 10 to the power 5, and then you can use this coordinate map, use number mapping to further process some query or something else. Really powerful data structure. That is it for maps. I'm gonna provide some problems for you to get familiar with it. But like, this is one of the most important data structures that you'll encounter in competitive programming, and you have to get familiar with it. Any questions regarding this?
If I index with like Java or something. What's the default value it gives me, and can I change that default value?
If you index with, oh, by default it's gonna be 0 for it. So what happens is, if you do out MP, sorry, MP, let's say random stuff, something else that is not actually there. So it's gonna output 0 for you. Whatever the default value of integer is, it's an output. Because the default value of integer is 0, that's why if it had this been a string, this would have outputted an empty string. Okay, but what is this? I'll show you one thing. All right, I'm iterating over the set before and iterating over the set after. Do you see the change?
Yeah.
It actually inserted the value random for me. And I did not intend to do that. So whenever you do like you call in something that does not exactly essentially is present in the map, and you index using that, it outputs 0 because it creates this thing. It creates actually internally first random dot 0. It's mapped to 0 and then it outputs it. So you don't want to do that. What if you don't want to? Actually, you just want to see whether something exists or not. How do you do that? For that, you'll have to use find. If I, instead of this, if I have this check over here, that if mp.find random, what happened? It's just kind of duplication of the law. Why is this throwing an error?
Wouldn't find return an iterator.
Oh, okay. I'm not checking that. Okay. Auto ID equals imperial find random. Yeah, thanks for that. And I have to actually have to check that IT not equals mp.end. Then do stuff, whatever you want to do. And then if I print this thing out, it does not insert the value random over here. So if you don't want it to actually add it, if it does not exist and you don't want to add it, then don't index it using this operation. Okay, use find for that first, and then check it and insert it. Because as soon as you index it, it creates by default a 0 value and then moves ahead doing whatever it has to do later. Okay. And by default, it defaults to whatever the default value of the second argument is.
Yeah, since it defaults to the value of the second argument, like if you are given like a problem where you have to count the number of times each string occurs or something like that, you can just do iterate over the strings and do mp_str++. So in the end, you will have only the map with each string and the number of times it counts.
Yeah, that's what counting the frequency of strings.
Sir, how are these stored?
This I told you now. This is internally a set of pairs, right?
Yes, sir, which in turn is a binary tree or
Binary
something like
search
that.
tree. Yeah.
So what are the preferences given if I give a string?
What do you mean by preferences given?
I mean, there's this comparator operator, right?
Yeah.
So 5 is less than
it's
6.
gonna refer to the comparator operator of a string. And what's the comparator operator of a string? It's the lexicographical order, right? The dictionary order.
Yeah.
For the string object, it is the dictionary order. It has been implemented in the string library that it has the lexicographical order. So it's gonna refer to that.
So it's essentially giving an index to a specific string, and we are accessing that I mean, it's just looking as if
yeah.
indexes
It's
are.
looking as if you're indexing. Okay, it's not a contiguous block of memory. It's just index operator has been overridden for your convenience. It is a set of maps. It is a set of pairs.
So
And
yeah, I think we
it's
can write step 1, step 2, step 3 and all on an array, right? Like we're using strings, right? Instead of indexing it as 1, 2, 3, 4 elements, we can write. I mean, it's just for a convenience, right?
yeah. I didn't get the step 1, step 2, step 3 part, but this thing is
Okay, I got it. Yeah, cool.
okay.
Thanks.
Okay, no problem. Anything else? Else we move on to comparators next, which
Sir,
is another really important thing, and then we're gonna finish it off.
in mp.find, if we aren't doing auto IT, why is it giving an error?
We aren't doing R2IT.
Like in line 8.
Yeah. Oh, auto IT. Because it expects you to return something. I was essentially doing if right. I had an if condition. C++ does not know what to do with an if condition if the return value is an iterator. If it's an integer, it's gonna treat it as a boolean value converted to true or false or whatever it is. But iterator is basically a pointer. There is no true and false typecasting of pointer, right? So it does not do what to do. So I have to assign it first and then compare it to MP.
Okay, so if we just remove auto IT equal to and just do mp find, will it like do nothing?
Yeah. Oh, interesting. Yeah, interesting should work. Cool.
Okay, sir. Thank you.
Okay, so I'll move on to comparators now. It's 8:32. So imagine you have got a struct or your own data structure, some kind of storage method, and you want to write a comparator for that. You want to sort it, or basically, you've got this thing struct point x in y in z. Then you have a vector of point vec, and when you do vec dot pushback, you want to pushback 1, 2, 3. It's going like the default constructor for this is like in order 1, 2, 3. I think Anirudh sir were talking about that before. So it's going to insert 1 to x, 2 to y, and 3 to z. And then there's 4, 5, 6. All right. And now you want to sort this vector of elements. But if you directly call sort begin and vec n, this won't work out because it doesn't know how to like I think by default it's going to look for the first value that is declared in the memory block. But suppose you want to sort it from the z order first, then y and the next. You want to give preference to z first. What are you going to do in this case? Like you'll have to declare some custom method of sorting, right? So I'm going to declare a function called a boolean function called compare comp, can be called anything. It's going to accept 2 arguments, point ampersand a and point ampersand b. Ampersand because I don't want to make copies and unnecessary copies, right? And I'm going to pass in this bool function over here. So what essentially does it? You guys would have written merge sort operation, merge sort, right? During the DSA course or whenever. At some point of time in your merge operation, you would have a situation where you actually compare the two values. That if this thing is, if you have in merge sort, you have a left array and a right array, then you iterate over the left and right arrays using 2 pointers, and then you compare 2 values. If my left value is the right value, then you place in the left value first. So instead of that left and right value, it's going to call that function in that particular place, this comp function to check. If this comp function returns false, then it's going to place in the first value, the left value first, and if the comp function returns true, then it's going to place in the second value first. So I compare if z a dot z is less than b dot c return is it true or false? I'll have to check this thing. I get confused between this. Should it return true or should it return false? Often takes me 2 attempts to find out, but we'll figure it out. So if a dot z and b dot z, if the zth value of my a is less, then return true. I want it first anyway. Else, if a dot z equals b dot c, yeah.
Shouldn't comp functions return int greater than positive if this
Oh,
comes
that
to us
was
as
in
negative?
C, but in C++, we switched to Boolean. In case it's equals, then if a dot y less than b dot y, return true. Essentially, rather than writing this thing, it's repetitive, right? I'm just going to return a dot y less than b dot y. But no, I need to have a check for that. Oh,
So I have a question.
Yeah.
So it's not possible to distinguish between double equal to and like greater than, less than here. Like, are we clubbing double equal to with less than or greater than?
Yeah, there's a reason for that. So it's whenever you're writing a custom comparator, there's a golden rule kind of thing that in case the two operators, the two functions are exactly equal, like not functions, sorry, your two arguments are exactly equal, it has to return false. That's how sorting in C++ works. If it doesn't return false, then it's going to give a segmentation for or throw some kind of error. And it's going to like remember that, clearly remember that. If in case these two values are completely equal, it has to return false. So often what people do is that they have an additional check always that if a is equals to b, or in this case if a dot x equals to b dot x and a dot y equals to b dot y and a dot z equals to b dot c, these return false, then move on. Okay, you need to have this thing. If all of them are equal, it has to return false, else it's gonna throw an error. It has happened to me during contests, and it feels really lame when you figure it out later on that this is why that happened. So please remember this thing. And a dot y.
Wait, C++ has and this like the word?
Yeah, this is C++ feature. I think some latest, some version of C++ added this thing. So instead of using and, you can actually use this keyword and. I like to use it sometimes because of like it's similar to Python, right? You can it's the same thing. You can use or, you can use XOR. It has it's a new version of C++.
Hypothetically,
Yeah.
like wouldn't it be like wouldn't we get a bit more information had we used like int here? We could say 0 for equality and like negative for
See, yeah,
false.
that's true. That's true. But it is how C++ has implemented the sort function. STL has implemented that it does not want you to return 0 in case of equal. It wants you to return false, because if you don't return false, it wants you to return false in case of less than or equal to, like whatever the case is. In two cases, it wants to return a false, and in one case, it returns a true. If you don't follow that, it's gonna give you a segmentation for or something, because it is the way that it has been implemented. If you look up the source code of sort function in the documentation and look at the place where they have this if condition, you'll probably understand why that happens. That if condition, and if condition is calling this comp function, if comp, then do this thing. So if you look that up, hang up, you'll find it out. One thing. Yeah, okay. Essentially, okay, this is taking too much time. I'm gonna remove this thing Z as of now. I'm gonna like I want to solve by y first and then by x. So if a dot y is less than b dot x, what? Sorry, b dot y, return false. I don't remember if it's true or false. Okay, I'll have to look it up. I forgot. I'll find it out. Else, if a dot y is greater than b dot y, return true. Else, in case they're equal, if a dot x is less than b dot x, return false. Else, if a dot x is greater than b dot x, return true. Else, that's the case when they're equal, return false. It has to be false, no matter what. I'm gonna get rid of this thing. And I'll sort it. Let's see what happens. And often, like, it's a good practice to have const here over here. That is because so that const ensures that you don't edit this thing over here, because you want to just compare them and give them back as it is. You don't want to actually edit them. I'm not printing them out. Okay. So it's sorted according to second value, right? So it so I think I might have been wrong about this thing. Let's switch this thing to true, this thing to false, false, true, true. Yeah, now it's fine. So in the case when it's equal, yeah, if you want a left element to come first, it has to return true. And if you want the left, yeah, if you want left element to come first, because if y is less than b dot y, I'm returning true. And in case they're equal, if x is less than b dot x, then I'm returning true. And in every other case, if you want, so if in case they're equal, the second element, in the case they're equal, you have to return false. That's the rule. And in case you want the second element to come before the first element, then also you have to return false. The reason for the equality sign, you can look it up in the documentation. I don't remember why, but I know the reason. Like, I know it's because of some if-else condition in the actual sorting logic. That's how you write the custom comparators for sorting. But like, comparators are not only used for sorting. Once you've written a comparator, you can use the same comparator to declare a priority queue, to declare a set, declare a multi-set. You can use these three things. Like, you can declare these three things using the comparator. Once you do that, your set will be sorted according whatever set you have declared. It will be sorted according to the comparator function that you've already declared. Your priority queues will pop out the least element. They pop out the maximum element always, right? By default, if you don't have the greater argument. So they're gonna pop off the on the top of the priority queue, the maximum element according to your custom comparator is gonna sit. And like, there's some syntax to declare priority queue using custom comparator or sets using custom comparators. You can look that up, but you can use custom comparators for declaration of data structures too, which involves some kind of sorted mechanism. That's it for the entire session. And like, please, I guess I'll try to find some problems that involve custom comparators. I remember some that I had to require. I had to write a custom comparator for priority queue in some code forces program. I'll try to look that up and I'll share it with you guys on Discord if that's possible. And that's it for this thing. If any doubts regarding custom comparators, you can ask. But please remember that that it's not only for sorting. You can declare custom comparators and you can use them for priority queue sets and multi-sets too.
And how does that greater angular brackets end function work?
Greater than what?
Means in the comparator we use the in for.
Oh yeah. Okay. So if you use this greater end thing, so it's but I think let's change this to integer and let's change this thing. Get rid of this. I think they are back. Yeah. So I think by default this thing, when you sort it sorts in ascending order, right? So that that also uses a comparator called, I think it's called a less comparator, and that's the default comparator. But there's also greater comparator, that's the opposite of this comparator. So you pass in this thing has probably been declared or somewhere in this library, and I think it will be algorithms library only. I don't know the name of the library, the header file, but it uses that comparator. It has been declared somewhere over there above, and you're essentially calling it greater. So it uses this internally. It uses the greater than operator. I think it's I can write this thing. Let's call it GRE. Bool GRE. It will be similar. Whatever the argument is, constant int a, constant int b. 1 second. Yeah, sorry. It probably just does this thing, return a greater than b. So in that case, it's going to return true if a is greater than b, right? Then true means that leftmost element comes first. In case of equality, it's going to return false. So this is essentially what this function does somewhere above. But the thing is, it doesn't only take an integer, it can take in any kind of value using templates. It can take float or anything. Yeah, that's what it is. Any other questions regarding comparators?
Ampersand A and constant point ampersand B, right?
Can you repeat it? I couldn't hear you.
You said we're using constant point ampersand A.
Yeah. Oh, it is a network problem. I'm facing some network issues. Once I'll change to my mobile network. Hello. Am I audible, Arpan? I changed my network.
Yes, sir, you're audible.
Yeah, cool. There was some network issue. Yeah. Can you repeat that once again? Sorry.
Yes, sir. So in that comparator function, we are passing the constant point ampersand A and constant point ampersand B.
Yeah.
One, like we're passing ampersand A to, I mean, not create more copies of that because point
exactly.
could be pretty large, right?
Yeah.
So why constant? It wouldn't matter, right? Even if we are changing it inside the function.
See, that's the thing. This comparator, the role of this comparator is only to compare them.
Compare.
Yeah, exactly. You don't want to change the array, right? You don't want to do a dot y equals 5. See, it throws an error because
we are still.
Yeah.
Yes, go.
Yeah,
I mean, we are just creating copies of ampersand A and ampersand B, right here.
No.
Still.
When you use ampersand thing, you're not creating copies. If you remove ampersand, then you're creating copies.
We're creating copies of addresses, right?
That address thing was there in C. Over here, it means that like over there you passed using ampersand and use this you pass the ampersand. You declared a pointer over here, and you dereference it over here, and you passed it in this function using ampersand somewhere here, right? As an argument, ampersand address. Yeah, that was there in C. Over here, the operator means something else. Over here, it doesn't. It means the address in some cases, but when you're passing it as a function argument, it means that whatever you want, it has to be by reference. It doesn't. You don't want to create a copy of that. The operator meaning is different in C++.
So, like, essentially changing A here changes the actual variable's address in main as well.
It doesn't change any address. It just refers to the same thing. It does not create a copy. That's the entire meaning of it.
Okay. So, I mean, like, we're using constant to not change A and B, right?
See,
I mean,
the role of constant is only if you remove the constant from here, you might accidentally edit it. You might do a dot y equals 5. It's gonna allow that. But as soon as you write constant over here, it creates an error because the compiler will see that you want it to be a constant, you don't want to change it, and you over here you're assigning it some value. So it's gonna create a compilation error before even the program is run, so that you know that you have to correct your code. That's so that you
So
don't.
if we remove constant and do a dot y equals 5, what change will there be in our main function or the actual variable?
Oh, it's gonna mess so many
Vec
things
dot
up.
begin.
See, every time it wants to compare this. Every time it will have to, like, there's an array, a sort array that you want to sort, right? So every time it will want to look at that index and want to compare with everything. Every single time it's gonna change the value to something else because it's gonna call the comparator function, right? So you're sorting the array while you're changing its value. That doesn't make sense, right? You don't want to
I
do that.
mean, it's not actually about comparator functions, sir. I'm talking about functions in C++,
Oh, okay,
about
yeah,
referencing.
yeah.
So, yeah, if I write a dot y equals 5, and that a is just an address, right?
Yeah, if I do change value in ampersand a is equals to 10 equals to 5. Yeah, okay. Let's get rid of this thing. Okay. It's passed on by reference. It actually changes the value in this case. It's going to print out a 5 and then a 10. However, if I remove this ampersand, it is not passed by value. It is passed as a copy. It's going to print 5 and 5. Clear?
So when you gave it the parameter as int ampersand a, there
Yeah.
a is an integer or an integer pointer, sir?
It's not a pointer. It's just telling that it's a reference. Okay. That was a C. It was called, and like that thing was there in C, that you like. It's true that you can actually refer to the address, but once I add integer before this ampersand, it doesn't mean address anymore. Okay. This thing itself would have referred to the address of it, but if I add this thing, it means that it's being passed by reference. The meaning of this term changes.
So yeah, any changes in this function will result in a change in main.
I think if I do ampersand a over here, then it's gonna print out the memory address of it. Over here, you're correct. Yeah, whatever the memory address is. But as soon as I add an integer in front of it, it becomes an argument that is being passed on. Okay.
Yes, got it. Thank you.
Cool. Any other doubts regarding differences or comparators?
I have a doubt regarding multisets.
Oh yeah, sure, please.
Why is deletion linear in the number of elements? Like at least in DSA, we were told that we can just have the tree so that the tree keeps like a count of the number of each element. So is it not implemented like that? Why is it implemented as like creating a new node for
There
each?
are two ways to implement, right? You can either store it as a different array or a different node, or you can creep a frequency of that thing.
Yeah. So isn't it fast with implementing it with
I don't
count?
know.
Isn't it log and deletion
Yeah.
always?
I don't think I don't know how it is implemented, but I'm guessing that it creates a different copy of a node or something every single time.
But why isn't that slower? Like
Uh, you could say it depends on your use case, right? You might want you to use a multiset only when there are only some of the elements may have multiple copies, not every element of them, right? So if you are storing a huge number of elements which are distinct and only some number of elements are multiple, then it's better to create a separate node rather than storing an extra frequency for every variable, right? It's going to take twice the number of memory, twice the amount of memory. So it depends on the use case. I don't know exactly how it is implemented. Does it use frequency? But I'm guessing that it does not use frequency. It creates a different count. It stores different nodes, and that's the reason that when you delete it, it deletes all of them. I think so. How it is implemented, you'll have to look that up.
Okay, yeah.
Okay.
And one more thing. So
Yeah.
when you do templatization in C++, like does C++ create new functions which correspond to like
No, it doesn't.
this?
It doesn't create new functions for floats or integers. It uses the same function.
No, I mean like yeah. So how does it do it internally? Like does it just
Because you do templating if your operators are valid for both the templates that are possible. So whatever the template is, I forgot the syntax of template, but I'm just gonna use the command thing to find it. So suppose you're using plus equals operator, right? So your template, the plus equals operator is allowed for integers, floats, long longs, all your numeric data types. It is also allowed for strings, right? You can use concatenation. So all of those things you can pass on in the template. But something where the plus equals operator is invalid, you can't use that. I think pointers, for example, doesn't allow plus equals. What's plus equals in memory address? Nothing, right? You don't want to change the value of a memory address by doing plus equals, so that's invalid. So in that case, in templating, that function would be invalid.
no? I mean like when you're like when you write a function to work for any template, like you put template t on top or something.
Yeah.
So like suppose like when you have a vector function that works for integers or for floats or whatever, like that at that point, like does C++ create like functions which do the instructions for the different types of data?
No,
Or
no, that's what I was talking about. It's that, see, whatever operations, whatever functions you have, I gave the example of plus equals. It has to be, it's your duty, the person who's creating the template, the class, he has to make sure that all the data types, whatever methods you do, should be applicable on the data types that are allowed for the template.
right,
So
but how does it generate code that like does equal like assignment for
it keeps only a single copy of the code, right? It keeps only a single copy of the code, but the operations that it does in those functions can actually be applied on any general object. It can be applied on integers or floats.
right? So how does that work? Like when it compiles, does it create instructions for both types of
No, it
objects?
does not. That would be like computationally inefficient. I'm guessing like it creates a generic instruction for them that can behave for any data type.
But like when you compile, like for example, doubles are 8 bytes, so there is a specific instruction for like 8-byte objects and stuff, right? So how can you just have like a generic instruction?
Oh yeah, that's a good question. I don't know then. Again, I'll have to take a guess for that. Maybe I'll look this thing up after the meet then. But I'm making a guess that it might create separate copies, separate instructions for just sizes of 4 bytes, 8 bytes, and all, like in multiples of two.
Cool,
Two,
okay.
2, 4, 8. It's like 1 for character, 2 for shorts, 4 for integers, and 8 for long, and all those things.
I don't
It might do
completely
that.
get the issue. Like, what was? Can you?
He's asking, like internally at some place there has to be some kind of static declaration, right? In the lowest possible level, there has to be some kind of static declaration of what is the data type, or what is the size of the data type. Or also, it might also be possible
No, it's
that
like it's resolved during compile time, right? So
yeah, he's asking, yeah, how is it resolved during compile time?
no,
So
like the compiler will figure out ki, okay, this function will run for int. Like this instance of this function will, like, here it means that int function. Like,
Right, so I'm asking like, does it generate code that handles ends, floats, and stuff separately? So, like when you write code for it, you just write for like a generic type T, right? So when it actually compiles, does it create a function for end? Does it create a function for float separately? Like,
okay, I'm taking a guess over here, Kishore, but I think it might be something like this. I'm not sure. Okay, when once you pass in an integer, it also stores. It knows that the integer takes 4 spaces, right? So it
right,
passes on the value 4 also, and when it's allocating memory and doing stuff for that, it ensures that it's 4. The 4 bytes are allocated.
cool, okay.
When you pass in a double, it stores the value. It passes on the value 8 too somehow through the compiler stack or like whatever that is. and then it allocates that 8 bytes of memory. So maybe that is passed on. I'm not sure. I'll have to look that up.
Okay.
I haven't gone through the compiler's course yet.
Yeah. Thanks.
When is like Urban? When does the compiler? In which year do we encounter the course? I
Third
haven't.
year.
Compilers is third year, like onwards. Like
Oh,
it's
is it
in their-
elective?
Yeah.
Okay, I'll take it. Cool.
So all these templating and everything is like resolved during compile time itself. So so yeah, there are different instances of the function it creates for uh, compile. Like I think for different data types. Okay, yeah, I'm not sure. You might have to look that up.
Yeah. But that templating doesn't create some additional time complexity. That's ensured.
Yeah, so there's something called template metaprogramming. Like this is it's interesting. So basically, C++ templates, the templating thing itself is, I think, Turing complete. So you can do a lot of stuff during compilation. So I'm not sure how exactly that works, but you might something called template metaprogramming and
Yeah,
some
I've
PLC.
I've
Okay.
seen them. I know like post stuff about Fibonacci calculation at compile time or something.
Yeah,
Yeah.
I'll just ping you here. Okay, I just joined, so I have no idea what happened.
Nice. Is it
Ping me
Gaurang?
where?
Do I hear
Yeah.
Gaurang? Oh, nice.
So
Okay.
yeah, so हाँ मतलब जो जब हम लोग मेटा प्रोग्रामिंग में तो कॉम्प्लेक्सिटी नहीं बढ़ती है वो तो, और वो
I'm
सबका
stopping
अलग ही
the
जनरेट है शायद.
recording. Okay.